Welcome to our new tutorial. Today, we would like to give you an overview of ENVIMET's model structure. The ENVIMET model basically consists of a one-dimensional boundary model, which includes vertical profiles of different meteorological parameters and a three-dimensional core model that includes all atmosphere, soil, building, and vegetation processes. At the bottom side, this three-dimensional atmosphere model is linked to a three-dimensional soil model, which reaches down to a depth of 5 meters. On a side note, the nesting area around the three-dimensional model domain shown here is a relic and should only be used when the model runs in cyclic or open boundary conditions, and even then, it is not recommended. We do not advise to use the nesting cells. Since ENVIMET only simulates part of the atmosphere, boundary conditions are required for the lateral and vertical borders of the 3D model. To provide these boundary conditions, the 1D boundary model generates one-dimensional profiles for meteorological parameters such as air temperature, specific humidity, horizontal wind vectors, kinetic energy, and turbulent exchange. To ensure stable laminar conditions, the boundary model extends to an altitude of 2,500 meters, which is the average height of the planetary boundary layer. The required input data needed to create the vertical profiles for the 1D boundary model are latitude, longitude, the date and duration of the simulation, the horizontal wind speed at 10 meters height, the roughness length, the air temperature in 2 meters height, the specific humidity in 2,500 meters altitude, and the relative humidity in 2 meters height. Currently, there are 3 types of lateral boundary conditions in ENVIMET. With open lateral boundary conditions, the values of the next grid point closest to the border are copied to the border each time step. In contrast, with cyclic lateral boundary conditions, the values of the downstream model border are copied to the upstream model border. The open and the cyclic lateral boundary condition types allow you to start simulations with only a few initial parameters and can be used for synthetic model areas to determine relative differences. However, with simple forcing, the values of the one-dimensional model are copied to the border. This boundary condition should be used for comparing realistic scenarios with real situations. For simulating even more realistic scenarios, in our upcoming winter release, it will be possible to define a diurnal cycle of vertical boundary conditions for various meteorological parameters. For example, radiation or cloud cover, wind speed and direction, air temperature, and humidity.